Okay, so the first thing you want to do is start with your bagels. I'm going to list my bagels. I have plain, blueberry, and raisin. So those are my three options of bagels. Okay, and I'm going to do my tree diagram horizontally and work this way versus going up and down just for the sake of room. Okay, with each bagel you can have what? Water or a sports drink. So from each bagel stems two more choices. Water, and I'm just going to label sports drink SD. Okay, and so when it comes to counting how many choices you have, you use the last column of work that you did. So I have 1, 2, 3, 4, 5, 6 choices of different combinations. So I can have a plain bagel with water, a plain bagel with a sports drink, blueberry with water, blueberry with sports drink, raisin with water, raisin with a sports drink. Okay, so sometimes you may have to use a tree diagram, or a tree diagram will be provided and questions will be asked based off the diagram. But if it doesn't ask or specify that you use the tree diagram, you can also just multiply your combinations out. So, how many bagel options did we have? 3. And how many sports drink or drink options did we have? 2. So you multiply your bagel options times your drink options, and that's going to give you your total combination. So we had 6 options.
That's all you can do?
Yep.
Is that for every single equation?
For counting principle, yes. So like, next one. When you get ready to get dressed for school, you open your closet to find that you have the following choices. A red, blue, or white shirt, jeans or sweatpants, tennis shoes, or sandals. How many different outfits can be made with these choices? So let's start with the annoying one first, which is the tree diagram. Red, blue, white. Okay, with each shirt, you can wear what? Jeans or sweatpants. So jeans, sweatpants. And then you can also wear what? Sandals or tennis shoes. So tennis shoes, sandals, tennis shoes, sandals, tennis shoes, sandals. I'm running out of room. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 combos. Or 12 outfits in this case.
You always have like the last part?
Yep, you always count your last column. But again, if you don't want to do the tree diagram, all you have to do is multiply all your options. So how many shirt options did we have? Pants options?
2.
And shoes?
2.
3 times 2 times 2 is 12.
Do you have to draw this diagram if it doesn't ask you to?
I just wanted to practice one more time. The important thing here is to make sure you're always multiplying. You do not add, you multiply. Alright, so probability is the way to measure the likelihood of an outcome. Okay, so an outcome is another word for an event or a result. Very good. So it's just any of those words are the same thing. For example, if a person has 5 shirts, 1 red, 1 blue, 1 white, 1 green, and 1 black, the probability of selecting a red shirt would be 1/5, since there's only one red shirt out of the 5. Just like the probability for a blue shirt would be 1 out of 5, and a white one 1 out of 5. Okay? So it's always going to be the one that you want over the total. Okay? So the number of ways that the event can occur or the outcome can occur over the total number of outcomes. Okay? If you set this up and you get 0 as your probability, that means that it's impossible. It cannot happen. So out of these shirts, if I ask you what's the probability of getting a pink shirt, well, there's not even a pink shirt in the problem, so it would be 0. Okay? Versus if I had 5 red shirts, and I asked you what would be the probability of pulling a red shirt, it would be 1 because all of the shirts are 5. Okay? So the remaining probabilities would be between 0 and 1. Okay? It would represent some sort of decimal that you could convert to a percent if it asked for. And you always want to make sure that your fractions are reduced. Okay, so always make sure you simplify your fractions. And remember, you can use the Math 1 key on your calculator. Okay, example, the student body at Wakeland High School is broken down as follows. Freshmen make up 582 students, sophomores 543, juniors 557, and seniors 498. If one student is selected at random, what is the probability that the student will be a junior? So we're looking for the probability that you select a junior. Well, how many juniors are there?
557.
557, and then what number would go in my denominator?
The total?
The total, which is 2,180. Can that be reduced?
No.
No. Okay. What if I were to ask you what percentage of the student body at Wakeland is juniors? 25.6? Very good. So you would divide 557 over 2,180, and then convert that to a percentage by multiplying by 100.
So you always multiply by 100 to get a decimal,
To give the percent, yes. Okay. This should say independent and dependent events, but it's okay because they split it up down here. When asked to find the probability of 2 or more events occurring, you need to determine if the events are independent or dependent. And not write as big as I did because I couldn't even put it on the one. Okay, an event is independent if its outcome doesn't affect the outcome of another event. So, for example, the probability that Maddie would win the 100-meter dash isn't going to affect the probability of Auguste winning high jump. Okay, those are 2 completely different events, and their outcomes do not affect each other. Okay, they have another example up here, like flipping a coin. So, if you flip a coin one time and you get heads, it's not going to affect when you flip the coin the next time whether you're going to get heads or tails. Okay? And if A and B are independent events, which means they're like mutually exclusive, okay, then all you do is you multiply their individual probabilities. So I'm going to multiply the probability of Auguste winning high jump and the probability of Maddie winning the 100-meter dash, and that would be my overall probability of both of them winning. Okay? So if a fair coin is flipped 3 times, what is the probability that every flip will land on heads? So I want the probability of 3 heads. Okay, so what? Yes. Joseph.
Would you just do 0.5 times 3?
Not times 3.
Or 0.5 times 0.5 times 0.5?
Very good. So you would do 0.5, which is 1/2, because the probability that you would get heads is 1 out of the 2 choices you have, heads or tails. Okay, so you have 1/2 times 1/2 times 1/2, and what do you get?
0.125.
Which is 1/8. Leave it as a fraction if you can. Yeah. Formula sheet? Yes.
I don't know.
Okay, so again, the kicker here is do not add them, okay? Huh? Donut.
Don't add them.
Oh, do not add them. Do not add them. Okay, so multiply them together always. Alright, example 2. A player rolls a dice twice. The number which the dice lands on the first time is X and the second time is Y. What is the probability that the product will be greater than 20? So I want you guys to go through and fill in this table. For example, 1 times 1 is 1 times 2, 1 times 3, etc. Fill in the rest of your table. Okay, if a question were to ask you the sample space, okay, a sample space is basically a list of your possible outcomes. Okay, so if I were to roll a dice, what would be my possible outcomes? 1 through 6, right? Because there's 6 sides to my dice. Okay, so my sample space would be 1, 2, 3, 4, 5, 6. Okay? If, what? Oh, sorry. Okay, if it asks about elements, okay, elements are the numbers that are within your event. Okay, so for example, number 1 would be an element, 2, 3, 4, 5, 6, 8, 9. So any number that's in your event would be your element. Okay.
Any number in your chart?
Yeah.
So all of them?
So all, but it's not just 1 through 36. Like for example, 7's not on here. 11's not on here. It would just be the numbers that are on here. That would be your elements. Okay. So just like if I have all these colors inside of my bag of marbles, okay, in that case it would actually be your sample space and your elements, because you can pull that and yeah.
You said your sample space is like how much, like if we had dice, it's like how many numbers you have?
Yeah, your dice is always just going to have 6 sides, which is 1, 2, 3. Remember, like playing Yahtzee, when you roll your dice, there's only 6 possible.
Yeah, that's what it is. Like
Yeah.
how many numbers.
Okay, so let's look at the question. What is the probability that the product will be greater than 20? Does that mean we include 20? Do we include 20? No. So the numbers that are greater than 20, how many numbers are greater than 20? Out of, and so reduce your fraction and what do you get? Very good. So making sure you read your problem. It's not greater than or equal to, it's just greater than. So if you were to include the 20s, you would get the answer wrong. So make sure you read. Okay, so opposite of your independent events. Opposite of your independent events are your, oh my goodness, I almost hit Sharon in the head, sorry. Opposite of your independent events are going to be your dependent events, okay? So the probability of something affects the next event. So let's see. If okay, we'll go back to track. Okay, the probability of a 4x4 team winning every single leg matters. Okay, so if the first girl trips and falls, that's going to affect the probability of the rest of the girls finishing first. Okay, or if I am picking cards, okay, and it's picking the order of which that y'all are going to do a speech in or something, and they're numbered 1 through 7. Okay, when you pick a card, and obviously if you take 7, okay, that one's gone. and then now I only have 6 cards to choose from, and then that person takes a card. And now I only have 5 cards, so the probability of getting the card that you want gets fewer and fewer tries. So, this is where a lot of these types of problems are in reference to a deck of cards. And that's why I had to go over with you guys your knowledge of cards, because second period didn't know, and on level, Coach Hegman and Miss Adams said didn't know anything about the cards either. So maybe on the last week of school we'll play like speed and war and 52 card pickup, because that's how many cards are in a deck. Okay, so to find the probability of these events, you take the probability of the event that you wish to occur first, okay, and you multiply that times the probability after that first event has occurred. Okay, so it sounds confusing right now, but as soon as we do some problems, I promise it'll get easier. So 2 cards are going to be drawn from a standard deck without replacement. Okay, this is the key to a dependent event, okay, when it says without replacement. It's not always going to say without replacement, but when it does, it's for sure a dependent event. Okay, what is the probability that both cards will be read? So how many cards do I start with? 52. And how many of those are read? 26. So that we know that simplifies to 1/2, because half of your deck of cards is red and half of your deck of cards is black. Okay, so now I want you to think, okay, that's my first event. So the first time I go at a deck of cards to pull a red one, I have a 1 in 2 chance of pulling a red. Okay, so now I'm done with that one. Now I'm pulling my second card. Okay, how many cards are in my deck now? 51, because I did not replace it. Okay, so saying that my first card that I picked was indeed a red one. Okay, so now with my second selection, what is the chance that I'm going to pick a red one? 25. Okay, so they each decrease by 1. Okay, so we know that this simplifies to 1/2. So what is the probability that you pick 2 red cards out of a deck? 25 over 102. Does that simplify anymore? Nope. Okay, example 2. A box contains 5 purple marbles, 3 green marbles, and 2 orange marbles. 2 consecutive draws are made from the box without replacement of the first draw. Find the probability of each event. Okay, so we're starting with orange and then green. What is the probability that I get orange? 2 out of 10. Okay. I'm not replacing. So now how many marbles do I have? 9. So what's the probability I draw a green one? 3 out of 9. Okay, 2/10 reduces to what? And 3/9 reduces to. So what is the probability I choose an orange then a green? 1/15. Very good. Are we hanging in there? Any questions so far?
Okay, so when it says without replacement, you add to the top and take away from the bottom?
You take away from both. So in this case, we didn't have to take away here because it wasn't orange then orange. It was orange and then green. Had it been orange then orange, we would have had to take away from the numerator and the denominator. So it's 2/10 because you have 2 orange out of the total, which was 10. And then after you have my orange marble in my hand, and I'm reaching back into the bag, now there's only 9 marbles in that bag, but there's still, 3 greens. Yep. Yeah, the only time you would put it in a decimal is if it asks anything about percent. And in that case, you're still not necessarily in a decimal, you're in a percent. Okay, so Maddie, here's this example. Both marbles are purple. Okay, what is it, Mads?
Okay, 5 out of 10.
First, very good.
And
Times
4 out of 9.
4 out of 9.
Please win it.
Yep. So if I have a bag of 10 marbles, okay, I pull one out and it's purple. Okay, so there was a 5 out of 10 chance that when I reached in there that first time, I was going to get my purple marble. Okay, now I'm not putting that purple marble back in my bag because it says without replacement. So now there's only 9 marbles in my bag. But keep in mind that this one's purple. So now instead of 5 purple marbles, there's only 4 left in here, and then there's 9. And then you have to multiply them together. Yep.
It's 2 over 9.
Oh, when you multiply them out, yes.
So you simplify it.
Yes. This is 2. Okay, last one is a purple marble first, and then any color except purple. So our first one's 5 over 10. Okay, without replacement, so my second number goes back down to 9. And then how many are left that are not purple? 5. Who said what?
Do you have to subtract the 5 from it?
So I have, I reach in and get my purple marble, right? So I have 1 purple marble here. I drop the number of my inside my bag to 9. And if I have 1 here, that means there's 4 purples inside the bag still. And 9 total marbles in that bag, so the difference is 5.
So, can't you just count the green and the orange?
And add them together?
Yeah.
So there's 5 out of 10 purple out of the 10.
Mhm.
Like, how do you know what color you're gonna pick?
The next one is anything other than purple, so my greens and my oranges.
Oh, so it's still 5.
Yeah. And then when you multiply this out, what do you get?
5 over 18.
Awesome. Alright. Any questions over the notes? Pretty simple, right? So far. Okay. Obviously it'll get spicier later on, but this is as simple as the intro gets. Okay. You have a classwork page that has 10 problems on it, and I had it somewhere, I don't know where it went. Okay, it has 10 problems on it, it's just a front side. You're going to work on that for the next 15 minutes. It probably won't take you 15 minutes. I'll kind of just gauge it based off walking around and seeing where everybody's at. And then we'll go through them up here. And then you'll study for a little bit, work on your homework. We'll take the skills check, and then anytime after class, at the end of the skills check, you guys can work on your corrections. Questions? No? Okie dokie.